Hello and welcome. This video tutorial serves to help you with the physics homework constant acceleration problems. There are a total of 10 problems we're going to work on. Please use my video tutorial as a template to help you solve yours. Let's begin. The first four questions are accelerated motion problems 1, 2, 3, and 4. The PDF for it, you will be able to do the work all on one page, like you see right here. For each question, you need to label the list of variables. Then you need to come up with the equation, solve it, and then display your answer with the proper units. Let's begin. Let's try accelerated motion problem number 1. Go ahead and put your name in there, and let's begin. All right, so for this problem here, it says your car will start at rest and accelerate at a rate of in my case, my acceleration is 5.48 meters per second squared until it reaches a top speed of 46.63 meters per second. So my initial velocity is going to be 0 because I'm starting from rest. So I'll make initial velocity 0. Keep in mind, they're writing it as VI. We typically write it as V naught and V. So just keep that in mind, the translation of the variables for this assignment. Our top speed was 46.63. Go ahead and put your top speed in your problem. My acceleration was 5.48. And I have to find the time and the displacement. So that means I'm going to section this off in two. And whichever you find first, it doesn't matter. There's an equation to find either one. I'm going to go ahead and find time first. And if I do that, you can see I'm going to be grouping these variables right here to find time. Well, if you look at your equation sheet, pause the video for a second, look at your equation sheet and see if you can select the right one. Well, hopefully you were able to select from that group V equals V naught plus AT. And that's equation number 8. Now we get to cancel out V naught because it's 0. And so our equation is V equals AT. Divide by A, and T equals 46.63 divided by 5.48. Go ahead and take a minute to put that in your calculator for your work and see what you got for your time. I got 8.51 seconds. Now for displacement, you can choose either equation 9, 10, or 11. I like equation number 11 a lot because it's very simple to work with. V initial will be 0. And when I plug in, I'm going to get V, which is 46.63 divided by 2 times 8.51 seconds. I'm getting a value for my displacement of about 198.4 meters. So I'm going to go ahead and enter those in my program. Okay, you can see the car is going to accelerate until it reaches that time. And there we go. I was able to get my question number 1 right. Hopefully you did as well. If you did not get question number 1 correct, go back and try it again. If so, on to number 2. Now, in number 2, you are going to be given, it says your car is driving at a constant speed on a roadway and you decide to accelerate around other traffic. The driver, well, in my case, the driver covers a distance of 170 meters while accelerating at a constant rate. Figure out that acceleration and the time the car was accelerating. Now, what you'll need is you'll need the speedometer over to the left for initial speed and for final speed. That's V and V naught. Okay. So let's list our information. For me, in question number two, my displacement is 170. My initial speed looks to be about 19 and a half. My final speed looks to be about almost 40. Gosh, I'm going to go maybe 39.9. All right, and I need to um, calculate the acceleration and the time. So both of those are unknowns. So again, split your problem in half because you have two things to work on. And you could solve for either one. I'm going to go ahead and try and solve this for A first. And if I do that, go ahead and pause the video and see which equation matches the list of variables delta x, v, v naught, and a. Hopefully you're able to select equation number 10, which tells us that v squared equals v naught squared plus 2 times a times delta x. Now, nothing cancels, so you have to take a little bit of time to solve for a. But in order to do that, first we're going to subtract v naught squared to the left. Then we will divide by 2 and delta x, like this. Okay, now we'll go ahead and divide by 2 and delta x together. Cancels, cancels. And a, we'll go ahead and plug in. Plug in your numbers, I'll plug in mine. For me, it's 39.9 squared minus 19 and a half squared, all divided by 2 times, in my case, 170. And I'm getting an acceleration roughly about 3.56 meters per second squared. Now you got to find the time. Well, for me, the easiest equation to work with is number 8. V equals V naught plus AT. I have to solve that for time, so I need to start by subtracting V naught from both sides. And my equation is V minus V naught equals A times T. To solve for time, I'll divide by acceleration. So time would be, now still plugging in my case, would be 39.9 minus 19.5 all over A, which we found to be, in my case, 3.56. Go ahead and take a moment to plug in your values. I'll plug in mine. I'm getting a time of about 5.56 seconds. I'm going to plug in my data. And there you go. All right, hopefully you were able to get question 2 correct yourself. If not, try again. If so, on to number 3. Go ahead and put your name into the program. Now, in this particular program, you are going to have a car that starts from rest and it will accelerate at a constant rate. You want to cover 100, in my case, you want to cover 187 meters in 7.76 seconds. It'll give you different distance and time. Your job is to predict the acceleration and the final speed. So let's see what I'm given. Starts from rest, I'll begin there. So for question number 3, starts from rest, 0. Okay, I don't know what the top speed is, and I don't know what the acceleration is. Okay, but I do know some things. I know the time is 7.76 seconds, and it's going to give you the displacement you cover. In my case, it's 187 meters. Well, you have to decide what you're going to solve for first. Okay. I'm going to go ahead and solve for A first. So to do that, realize I have delta x, displacement, V naught. I'm looking for A, and I've got T. So with this, I can use equation number 9. Delta x equals V naught T plus 1/2 AT squared. Now, notice if V naught is 0, then the whole middle term V naught T cancels out, which helps me rewrite the equation delta x equals 1/2 AT squared. Now, to solve this thing for A, I have to get rid of 1/2 and T squared. So I'll start by doubling both sides. And I get 2 times delta x equals AT squared. Well, now A is multiplied times T squared. So the opposite of multiplying by T squared would, of course, be divide by T squared. A would be equal to 2 times delta x over T squared. So 2 times whatever your displacement is, minus 187, over your time, whatever your time is, and don't forget to square that. In my case, I'm getting an acceleration of about 6.21 meters per second squared. Go ahead and see what you get. Now, to find my final speed, I can just use equation number 8. Right? Simply put, remember the initial velocity was 0, so I get to cancel that. And my final speed, which is called the top speed in this problem, is going to be my acceleration times my time. And I'm getting a top speed of about 48.2 meters per second. I'm going to go enter in my data. All right, see how I did. The car will accelerate to the time you calculate, 7.76, and there you go. I was able to get it right. Hopefully you were able to get this question right as well, too. Excuse me. If you did not get it right, obviously go back and try it again. If so, on to question 4. Let's put our name in the program. Now, in this problem, it says a car is moving with a speed shown on the first speedometer, the initial speed, when a squirrel enters the roadway and plays possum, meaning plays dead. The car slows down with a constant acceleration until the point where the squirrel decides to go back up the tree. The new speed of the car is now shown with the second speedometer. In other words, what you slow down to. Based on the speedometers, what is the time the car was accelerating, or decelerating in this case, and the distance covered while you're negatively acceleration. Remember, if it's slowing at a rate of the acceleration, your acceleration is going to be negative. So my acceleration is negative 3.43 meters per second squared. All right, let's go ahead and list what we know. For me, I know that my acceleration is negative 3.43 meters per second squared. Okay, I know that my initial speed, when I look at the speedometer, is about 26 point, I don't know, 8 or 9. Go ahead and estimate yours. And my final speed, when I look at the second speedometer, is down to about 11 point something. That's pretty close. That's so much. I'd go ahead and estimate that about 11 and a half. Okay, and remember, we have to estimate the time for acceleration and the displacement of that acceleration. So those are our unknowns. Split your page in half. I am going to choose to solve for time first. So that groups these variables together. And that would be using the equation number 8. V equals V naught plus AT. Go ahead and subtract V naught from both sides. Rewrite. And we get V minus V naught equals A times T. Divide by A, and T equals, we can plug it at this point, 11.5 minus 26.8 over negative 3.43. Notice your top speed will be less than your final speed. So just keep that in mind. Okay, your initial speed will be less than your final speed, giving the numerator a negative value, like mine, dividing by a negative acceleration, which will give you, of course, a positive time. 4.46 in my case. Well, now when you find that, go ahead and choose an equation to help you find displacement. I really like equation number 11. It works pretty quickly, so I'm going to use that. V plus V naught over 2 times T. Plugging in, we have our final velocity, 11.5, plus our initial velocity, 26.8, divided by 2 times whatever your time was. Mine was 4.46. Go ahead and take a moment to figure out your displacement. In my case, I'm getting about 85.4 meters. Okay, go to the program, enter in your information, and let's see how you did. All right, and there you go. I was able to get question 4 correct. Hopefully you were too. All right. If you were able to get this correct, let's move on to number 5. Now, questions 5, 6, 7, 8, 9, and 10 have their own PDF. Okay, so open up those. This is going to be accelerated motion question number 5. Okay, and go ahead and enter your name into the program. Now it says the Jersey Jet, okay, which is going to be a bobsled. It crosses the finish line, and you can see mine, and I'll just go ahead and reset that. Let's see. Okay, so you can see the Jersey Jet, it's going to cross the finish line, and then it's going to come to a rest. Okay, so you have to use the scale at the bottom to figure out the displacement that it took, because at the finish line is when you start braking, and it took a certain displacement to come to stop. For me, it was about, looks to be 79 point, I don't know, 2. Okay, so first thing I'm going to do is I'm going to make my list of variables. Well, actually, first thing I ought to do is put my position on here, and let's list the information. So I have a displacement of about 79.2 and a time of 3.519. So the time time of 3.519 seconds, a displacement, in my case, of 79 point, I don't know, I'll say 2. Okay, now here's what we got to do. The first part we're going to do is we're going to find the average speed. Well, there's two ways to calculate average speed, actually. One is, well, displacement over time. We're going to do that one first. Go ahead and divide your two. The other equation we have for average speed is the sum of your final and initial velocity divided by 2. We'll come back to that one in a second. So I'm getting an average speed of about 22.5 meters per second. Okay, now if I use the second equation, V equals, or V average equals V plus V naught over 2. Now, what we'll do is we're going to now use this to find the top speed, which is the initial speed, keeping in mind that the final speed was 0. So let's put that over here. Okay, V average equals V naught divided by 2. You can see all we have to do is just multiply both sides by 2. And that V naught is really just twice. When the final speed is 0, the initial speed is just double the average. So if I go ahead and double that, I get exactly 45. So I got my average, I got my top speed, and now lastly, I'm going to find the acceleration. It's going to be negative, okay, but I'm going to go ahead and find that. Now I could probably, since I've got a displacement of 79.2, my V is 0, my V naught is, I don't know, what was my V naught? Oh, 45, I just found it. My acceleration is what I'm looking for, and my time was 3.519 seconds. Just check that real quick. Yes. Okay. Now, I could choose any group of equations I want. Any one that has acceleration. Equation 8, 9, or 10 all have acceleration. I like to use equation 8 because it's simple. So I'm going to group those variables together. That would give me the equation V equals V naught plus AT. V is 0. Subtract V naught to both sides. Negative V naught equals A times T. Divide by T, and A is equal to negative V naught over T. So negative 45 meters per second over 3.519 seconds gives me a negative acceleration of negative 12.8 meters per second squared. All right, let's enter these three values into the program, see how we did. Enter yours, I'll enter mine. All right, there you go. Question number 5 correct. Hopefully you were able to get it correct as well. If you got it right, let's go ahead on to question 6. Car acceleration. Okay, so you have a self-driving car and it's been programmed from rest to a certain rate for a certain amount of time. You got to predict how far the car will travel during the acceleration and the speed at the end of acceleration. So I've got my acceleration and my time. I'm starting from rest, so let's list the information we're given here. Okay, so write down the acceleration that the car will have. So we have A in my case is 5.1. Whoops, wrong one. A is going to be 5.1. Second. There we go. 5.1 meters per second squared. And my time was 5.4 seconds. So I'm going to go ahead and fill out the information that I know here. So I got 5.4 seconds. And 5.1 meters per second squared. Okay, perfect. Now what I'm going to do is I'm going to predict the displacement and the final velocity. And when I go to check, the car will run and it will check and see my answer. So, oopsie. I think I accidentally deleted it. All right, let me go back. There we are, back again. Okay, so I don't know. I also know that V naught is 0 because I'm starting from rest. I don't know the final speed and I don't know the displacement. Okay, so what I'm going to do, I'm going to make two parts. All right, and the first thing I'm going to do is I'm going to solve for V final using that group of variables. Well, equation number 8 will help me with that. V equals V naught plus AT. Remember, V naught is 0, it cancels. And V would equal 5.1 times 5.4 in my case. And I'm getting 27.54 meters per second. Okay, now to find the displacement, choose whichever one you want. I like equation number 11 a lot. Again, initial speed is 0, so my displacement would be your final speed, 27.54 over 2 times 5.4 seconds. And I'm looking at about 148.7 meters, roughly. Okay. Now, the second part of the question says, assume the car didn't assume the car didn't start at rest, but instead was rolling at 5 meters per second when they started their acceleration. So, in other words, the acceleration was still the same. So 5.1, 5.4, but had an initial speed of 5 instead of 0, right? How much time would it need to accelerate? Oh, sorry. So that would be the question mark. How much time would it need to accelerate to reach the speed, and how much ground would it cover? So it's the same top speed as before, 27.54, right? And for that one, we're going V equals V naught plus AT, right? And you're just solving for time. So what I'll do is I'll subtract B naught and divide by A. So V minus V naught over A would be 27.54 minus 5 over 5.1. Okay. That would be about 4.42 seconds. So it takes a little bit less time to, if you're already going a certain speed, to accelerate to that speed. And how much ground would you cover? You know, if you look at your displacement, it would be 27 point, 54 plus 5 divided by 2 times 4.42. I'm getting about 71.9 meters. Okay. Now, I believe in the program, you're only putting in the values for displacement and final velocity. So not the last part, but the initial part. So I'm going to look at my values. I got a displacement of 148.7. Okay, and I got a velocity of 27.54. Okay, it's going to run the program. Let it run. And no, I didn't get it right. Well, time to try that one again. This does happen every once in a while. Let's see. Try that one again. Okay, so enter in my values. All right, I'm going to focus on the top part, not so much the bottom part. So all I have to do is really just change some values there. Don't really have to change a whole lot. Okay. Oopsie. Okay. All right. See, acceleration 4.41. Oopsie. And I can always try a different equation. I mean, 11 should work, but it doesn't hurt to try something new. I mean, I could try the V naught times T plus 1/2 AT squared. We'll see. We'll see what happens. Like I said, every once in a while, we're going to make mistakes. Just correct them as you go. So my acceleration was 4.1, and my time was 4.4. So 4.1 times 4.4. And I noticed I got my top speed right, but I got my displacement wrong. So that's okay. Let's figure it out. So my displacement is going to be my V naught T. So V naught is 0, so that whole middle part does go away. 1/2 times my acceleration, 4.1, times my time, 4.4 squared. Let's see if I get this better. 4.4 squared times 4.1 divided by 2. I'm looking at 39.7 meters. All right, second time's the charm, right? Let's see. 39.7 meters and 18.04. There we go. Okay, I got it this time. So sometimes you're going to make mistakes. Obviously, I did too. It happens. Okay, just be prepared to go back and try it again. Maybe you missed a calculation. I probably just missed a calculation last time. That certainly does happen. Okay, now on to question 6. Speed from stopping distance. Okay, so we're given the acceleration, negative 6.72. So I'm going to fill that out. Negative 6.72. It says click on the car to start its motion toward the braking zone that begins at the 0 mile. At that point, the driver will slam on the brakes and start skidding until losing speed at the rate indicated. All right, well, let's start. Okay, so we need to figure out the displacement from the picture. Okay. And from the picture, it looks like for mine, it's about 143.6, 0.7. Uh, let's see, I'll go about 143.7, somewhere around there. Now it gives me also, let me see, my final speed. My final speed would be 0, okay, because I'm coming to rest. And I don't know the initial speed and I don't know the time, okay? So what I'm going to do is I am going to find, I need to find the initial speed and I need to find the time. Well, let's see what we could do here. Um, I could group these variables together right here. Let me see. No, because I don't. Yeah, I could do that. I could group those variables together to find the initial velocity, and that group of variables would correspond to equation number 10. V squared equals V naught squared plus 2a delta x. Now, V final is 0, okay? And realize, guys, in order to solve for V naught, you have to solve for V naught squared. And the easiest way to do that, honestly, is just go ahead and subtract this whole value of 2a delta x over to the left. If you do that, V naught squared is all by itself. So V naught squared, I'm rearranging the equation, is equal to negative 2a delta x. Now to solve for V naught, just go ahead and square root both sides, like that. So my initial speed, initial velocity is going to be equal to the negative of 2 times my negative acceleration, in my case, negative 6.72, times my displacement, 143.7. Put that in your calculator. Notice the negatives here will cancel. So you need to put that in your calculator. 2 times 6.72 times 143.7. Don't forget to square root that. I'm looking at a top speed of about 43.9 meters per second in my case. Okay, now when I've got that, I can solve for time using equation number 8. How do I do that? Subtract B naught, divide by 8. So when I plug in my values, I have a 0 minus 43.9, so basically 43.9, divided by A, which is negative 6.72. So 43.9 divided by 6.72, I'm looking at about 6.53 seconds that it takes. Okay, don't worry about step 4. Let's plug in our numbers and see how we did. All right, there we go. Successful with question 6. All right, if you were too, let's go on to question 7. Question 7 is prediction from a constant acceleration graph. My first time doing this one, I got it wrong as well. So it is very easy to get this one wrong. So I'll walk you through how we get it right. Now, the first thing I'm going to want to do is I want to find the initial velocity from the graph. Okay, and from my graph, it's pretty much dead on 11. So my line starts at 11 and goes all the way up to 32. So I'm going to go ahead and make my graph. So I'll go to here, go to shapes, and I will make my graph. I'm going to go from 11 all the way up to 32. like that. Okay. Now, what I'll do is I'm going to go up and I'm going to figure out my slope. So my slope is going to be easy because I'm going to go up from 11 to 32. Okay. And so the rise, I can basically go, rise over run. I can do that. Okay. So my rise would be 32 minus 11, which is 21. And my run, I mean, it's the full graph. It's 20 seconds. So I'm looking at a slope. Okay. The acceleration, oops, sorry. The acceleration is my slope, okay, which is rise over run. And in my case, it was 21 over 20. Go ahead and figure yours out. I'm getting an acceleration for about 1.05. Wrong one. Okay, so my initial velocity was 11. My acceleration was about 1.05. And my displacement, now to find the displacement, I've got to figure out the I have to see. I've got to figure out. I have to figure out the time because we have to find the displacement for only the shaded region. So, you know what, for that one, okay, for that one, I am going to use equation number 11, v plus v naught over 2 times t. What you'll have to do is you'll have to get v and v naught from the graph, and you'll have to predict the time interval. Okay. So oops, sorry. My initial speed looks to be exactly at 3, and my final speed appears to be exactly at 16, 17, 18.6. Okay, now the time frame goes from 3 seconds to 18.6. So if I go, oh, glad I caught that mistake. Those are the times. So 18.6 minus 3, that's my time interval. So that's 15. So let me erase that. Ooh, I'm glad I caught that. 15.6 is my shaded time interval, and I just got that by subtracting 18.6 and 3. Now I got to find the speeds. I didn't do that. Okay, so my speed to start the yellow region is, it looks like it's about 14s to start with, and it's ending at 29 and a half. So 14 and 29 and a half. There we go. Okay, so 14 plus 29 and a half divided by 2 times 15.6. I'm getting a displacement of about 339.3. All right, let's see how I did. Wrong one. All right, there we go. Able to get it correct. All right, if you were able to get it correct as well, on to question number 9. And question number 9 is called Two Stages of Motion, Problem Level 1. Okay, in this one here, your car is going to make a 400-meter run. Your car will start from rest and accelerate at a rate of 4.23 meters per second squared. Let's enter in those numbers. So for me, make my list. And actually, we're going to make a chart. Okay, we're going to make a chart. The chart is going to look like this. So we have constant acceleration, and then we have constant velocity. Okay, constant acceleration and constant velocity, because that's what we were told. The car starts from rest, gets to a top speed, and finishes the rest of the 400 meters at constant velocity. So let's figure some things out. For constant acceleration, make your list. Delta x, v, v naught, a, and t. I know v naught is 0, and I was told that the acceleration is 4.23 meters per second squared. Okay, let me see here. Oh, keep going the wrong one. Okay, the process lasts for 4.26 seconds. So from this, you can find two things. You can find how fast you're going, which would be the speed that you keep going with, and you can find how far you went. So we're going to find both things. First, let's focus on how fast we went. To do that, we'll use equation number 9. I mean, no, equation number 8. Equation number 8 will work. So V equals V naught plus AT. V naught cancels. V would be 4, in my case, 4.23 times 4.26. And my top speed, let's see here, would be 18.02 meters per second. That is going to be the same as the constant speed here. So for part 2, constant velocity, you only have 3 variables: displacement, velocity, and time. And your displacement will be 18.02. Well, mine will be. Figure out yours. Whatever your top speed is, that's your displacement or your velocity for the rest of the way. Let's figure out the displacement. So I'm going to use equation number 11. So we've got V plus V naught over 2 times T. V naught was 0. And it's going to be 18.02 divided by 2 times 4.26. And delta X for this region is, let's see, 18.02 divided by 2 times 4.26, about 38.38 meters. Now remember, this was a 400-meter race. That means the rest of the displacement is going to be 400 minus that value, whatever you got. So 400 minus, in my case, 38.38. And the rest of my displacement is 361.62. Now we're going to use that to solve for time. That's pretty easy because V equals delta X over T. So flip them. T equals delta X over velocity. And it's 361.62 meters over 18.02 meters per second. And the time for the constant velocity portion is about 20.07 seconds. Okay. All right. So now what we're going to do, it says show the 2 different areas on the racetrack below. So basically for 38 meters, so, 50 is here. So for 38 meters, this is the constant acceleration part. The rest of this is the constant velocity part. Okay. Now we have to find, in order to finish this problem, you can see we have to find the top speed. That's the speed we get to and what we run for the rest of the time. Mine was 18.02, enter yours. And the total time, in order to find the total time, we have to add the times. Okay, we have to add the times. So find the time required for the second part. I did that. I'm just going to put that information back down here again. So time equals 361.62 divided by 18.02, and that was about 20.07 seconds. Okay. Now, using that, your total time is just the time for part 1, T1, plus the time for part 2. So it should be, my case, 4.26 seconds plus 20.07 seconds. And I'm getting a total time of about 24.3 seconds. Let's see how I did. Okay, it's going to accelerate until it reaches your predicted values. It'll take a minute to get up to 24 seconds. You can see it's going at a constant speed right now. All right, there we go. Hopefully you were able to get question number 9 correct. If you were able to get question number 9 correct, on to our final question, number 10. Go ahead and enter your name in the program. Now, this is called two stages of motion problem level 2. Well, it's going to be similar. The difference is we don't have a set distance that we're going to be traveling to. We have a set time of 20 seconds that we'll be doing. But the process is the same. We start from rest and accelerate until you reach a certain value. My value is 4.05, so I'm going to enter that. I'm going to make my chart just like before. Constant acceleration, constant velocity. My variables, delta x, v, v naught, a, and t. Starting from rest. Mine was 4.05. Okay, and my top speed was 37.9. I have to figure out the time for part 1 and how far I went. So let's find that work. All right, I'm going to use equation number 8 to find the time that it took to accelerate. So V equals V naught plus A times T. Notice we're starting from rest. So to solve for T, we just divide by A. Easy. So the time for part 1 is going to be my velocity, 37.9 meters per second, over my acceleration, 4.05 meters per second squared. Okay, let's figure this out. 37.9 divided by 4.05. I'm getting time 1 of about 9.36 seconds. Okay. And I guess that kind of goes down here. Now, to find the distance to reach that top speed, choose whatever equation you want. Okay. Again, I really like equation number 11, so I'm going to use that. V plus V naught over 2 times T. V naught again is 0. Plug in. Top speed was 37.9. Take half of it times your time. Okay, so 37.9 divided by 2 times 9.36. So I'm looking at a displacement of about 177.4 meters to accelerate. So that's how long it's going to take me to accelerate. That's how far it's going to take me while I accelerate. Now, to find the total distance, we need to basically do the following. Okay, we've got the time. Now, over here, we don't know what the distance is. We know what delta x1 is. We just found it. Delta x2, we're going to need to find it. We know the velocity is going to be the same as your top speed. So that's 37.9 in my case. Figure out yours. And the time, well, guys, that's going to be 20 seconds minus what you got. Remember, it's running for a total of 20 seconds. So just go 20 minus the time you got for part 1. In my case, that's 10.64 seconds. Okay. Now, using that information, I can find the displacement for that. So I'm going to find the displacement for part 2. And it's V equals displacement over time. So if I multiply both sides by time, displacement for part 2 equals average velocity times time. That would be, well, your constant velocity times time. That's your 37.9 times the time for part 2, which in my case was 10.64. 37.9 times 10.64. I'm getting about 403.3. Okay, so now add them up. Delta X total is going to be your original one, which in my case was 177.4 meters plus 403.3 meters. Add them up. Okay, I'm getting about 580.7 meters. And on the track, I just need to kind of show where that ends at 20 seconds. So 500, there's 600 right there. So my car is going to get to about right there, roughly. At least that's what I'm predicting anyway. Let's see how I did. Okay, I have to enter the top speed. So my top speed was, wait, was it the top speed? No, time to top speed. Okay, so basically time one. Time one was 10.36 seconds. No, nine, sorry. Just double check that. 9.36 seconds. Okay, so 9.36 seconds. And then the total displacement I got was about 580.7. All right. Okay, it's going to accelerate until it gets to 20 seconds, and we'll see how far we went. And there we go. I was able to get question number 10 correct. Well, hopefully, ladies and gentlemen, you were able to get all 10 questions correct yourself. I hope you found this video tutorial to be helpful. Remember, go back and pause and rewind it as needed. And if you're still struggling with it, come on by and talk to me about it. We'll get that worked out for you. Thank you. See you next time.